Okay, this video is for my pre-calculus class, and we're modeling with exponential and power functions. This is the lab we're talking about. And our new unit, we've been talking about power functions, and the best way to learn about how to find power functions, if I give you a couple points, is to find the exponential function that we used to do and then compare it with how we would find a power function giving these set of points. So the one thing I want you to remember is that exponential functions are, we used y equals ab to the x. Notice your variable is an exponent, okay? So a and b were constants when we got done, okay? And then when we do power functions, they use a k for a constant. Your variable x is down here and your power is here. So again, this is a power function because your x is down low, if you will. All right, so let's kind of do what we used to do for y equals ab to the x, and I'm going to show you that they're very similar but different to find your exponential, your power function using the same 2 points. So the points we have here are 212 and 575. I like to stack and rack them, okay? And because I don't know my initial value, which is my a, I'm going to plug them in the formula. So I have 75 as my y value equals ab to the fifth, divide, and then I'm going to put 12 equals ab to the second. So recall what we did was y equals ab to the x. This is my x here and my y, and all I did was plug them in those spots. By doing this, I noticed these can cancel out, okay? And then I have 75 over 12 equals b cubed, because if I have the same base and I'm dividing, I subtract my exponents. Now, because I don't want b cubed, I want b, I'm going to raise both sides to the 1/3, so I get b to the first. I end up being 1.84202. Now I'm going to write y equals a. My b is now 1.84202 to the x. And now all I'm going to do is plug in one of the points. So I plugged in the 212. So in the y spot, I put a 12. In the x spot, I put a 2. Since these are hooked by the a by multiplication, I can divide by that. So a is going to equal 12 divided by 1.84202 squared. And when I do that, I'm just going to go a couple decimal places. I get 3.54. So if they wanted me to model an exponential function, I have y equals 3.54. That's my a. My b is 1.84202 raised to the x. So that is my exponential model using 2 points. Okay. Now, this is going to be a little bit different, but yet the same. You are now going to use y equals kx to the p, or kx raised to the p, and we're going to use these 2 points, 212 and 575. X and y are still the same, so I'm going to use 75 equals k. Now, the 5 is going to come down here, raised to the p, divide, because it's a ratio. I'm going to put in 12 equals k 2 raised to the p. Again, these will cancel out, so I have 75 over 12 equals. Now, this is where it's a little bit different if they're both raised to the same power. So remember when we did exponents, I said you can combine exponential functions if either the bases match or the powers match. Well, the powers match, so I can write it as 5/2 raised to the p. Okay? Now, here is where you look at and you say, okay, that p is an exponent. I've got to actually, the only way I can solve for that is to natural log both sides. So I have the natural log of 75 divided by 12 equals the natural log of 5 over 2 raised to the p. And remember our log rules, I can bring the p down front. So I have log of 75 over 12 equals p natural log of 5 divided by 2. And then I'm solving for p, and these are hooked by multiplication. So p is going to equal the natural log of 75 divided by 12 all over the natural log of 5 divided by 2. And when I put that in my calculator, I get a 2. All right, so that's nice. So I'm going to come up here and say, all right, y equals So I know that my power is 2. I have kx squared. Okay. Now I'm just going to plug in one of the points. I'm going to use 212 again in the xy spot. So I'm going to put a 12 here because I want to know what k is. I'm going to put a 2 here. 2 squared is 4, so I have 12 equals 4k. Divide by 4, k is 3. So my power function using these same 2 points would be y equals 3x squared, which is clearly a lot nicer number than what we started out with. Okay, so both of these are representations of 2 different kinds of functions with the same set of points.